now that we discussed about the history of aircrafts, how they developed and how we are using these aircrafts now, I'm sure you know of lot more uses of these aircrafts. Now let us look at, what all, what are the common examples of aircrafts? Again, most of it you guys already know. Let me list them out again, right? Hot air balloons. We already talked about balloons, hot air balloons, whatever it is, are are effectively aircrafts. They are airborne systems, right? And then there are some things called dirigibles or airships. I'll come back to them, right? These are effectively hot air balloons with some propulsion unit, right? Hot air balloons generally fly wherever they want to fly, right? They have no control. Whereas dirigibles and airships have a propulsion system which will make them, turn one way, go to a particular place, or which will help us go from one place to another place, right? These are called dirigibles or airships. Then there are kites. Patang udana. I'm sure a lot of us have flown kites. So these kites are one set of aircrafts. Then there are gliders, right? Gliders are unpowered, right? Cannot fly for too long a distance. And then there are airplanes, right? What are airplanes? They are fixed wing aircrafts, the kind of aircrafts that you use to travel from place A to place B nowadays, right? There is one fixed wing there, and then that's fixed with that fixed wing. You are taking off using a runway. Then there are rotorcrafts, helicopters, multi-rotors. Most common form of multi-rotors that we use are all these quad rotors, which you see everywhere nowadays in marriage videos, wherever, any place where we want to take videos also, there will be a small quad rotor buzzing around and then taking the video. And then there are flapping wing aircrafts which we have developed, that is ornithopters, insectopters and so on. So these are all the common examples of engineered aircrafts, right? These are all the aircrafts engineered by human beings, right? So that's what we are looking at right now. So these common examples of aircrafts can be broadly classified into two. The first one is called aerostats. Aerostats are nothing but lighter than aircrafts. What do I mean by lighter than air? If I look at hot air balloon, that's an aerostat, right? So what happens in a hot air balloon? I am filling the balloon with gas, hot air, whatever, which has less density than the surrounding air. So in that sense, that hot air balloon is lighter than the surrounding air. So and hence we call it as lighter than air flight. The density of the balloon itself is lower than density of air outside, right? So that is your balloon. To that balloon, you can just stick, kind of a propulsion system, and that becomes an airship or a dirigible. These are all lighter than air because they use buoyancy effect, right? Because density of air inside the balloon is less than density outside, they use buoyancy effect to stay afloat. So you can see the picture of the Zeppelin, which was a airship here, and of course there is this Zeppelin which looks like nicely like a modern day aircraft. In fact, the first time I saw this Zeppelin image was when I was a high school kid, and I thought this long tube which has word Zeppelin written on it itself was the fuselage way, and the people are sitting inside that. That's not actually correct. That big tube on top is filled with hot air, and then you see a small thing at the bottom. There is a small thing with some 4 windows at the bottom. That is where passengers are sitting, right? There's a small passenger compartment, and there is this huge hot air balloon which is shaped kind of like a tube, like a modern day fuselage, but that is actually hot air balloon, or in some cases they may not be hot air, some lighter than air balloon, right? So that's what it was, right? That's what airships were. Of course, one of the disasters which happened with these airships was something called Hindenburg disaster. That was a hot air balloon, or rather that was a balloon or a dirigible balloon with some propulsion system that had hydrogen filled, because hydrogen is lighter than air. Unfortunately, it caught fire and everybody died. These are all massive. Balloon and dirigibles are all really massive. Why are they so massive? We'll learn about it in the rest of the course. They are not so practical, though we do use it for some surveillance and other things nowadays. The second kind are called aerodynes as against aerostats. Stats comes from static, right? Hot air balloon and dirigibles don't depend upon relative motion between the vehicle and the air to be airborne. They just depend on the fact that they are lighter than air, which is buoyancy force will make them afloat. So there is no need for relative motion, and hence it is static. Hence it is aerostats. Then there are certain things called aerodynes. These aerodynes are heavier than air flight. What do I mean by heavier than air? The material that they are made of is heavier than air. Density is more than that of air. So, in a natural state of things, anything which is denser will come down. It can never go up. So, if it is just static, then it cannot, there are no forces other than, gravity and other things, and this is heavier, so it will settle down. So, if we want to keep this aircrafts in motion, right, and want them to be airborne, then we have to use aerodynamic forces. How are these aerodynamic forces generated? Briefly, we'll learn about it in the later part of this course. But yeah, effectively here what happens is this aircrafts move, related to the air, as either there is air is, I can assume air to be kind of stagnant, and this aircraft moves forward into the air, cutting into that air. As it cuts into that air, the aircrafts are shaped in such a manner that there are certain aerodynamic forces generated, lift generated, and so on, and that lift balances your weight, and that's how it stays airborne. Though it is heavier than air, it stays airborne because there is relative motion between aircraft and air. Because of that relative motion, there are certain forces that are generated. Those forces lift it off from the surface of the earth, right, balancing the gravitational pull, right. In fact, it will overcome the gravitational pull, right. Those are all aerodynes. What are the aerodynes? Kite is an aerodyne, right. Kite, if you just leave the kite like this, it will just drop, right. You have to make sure that there is relative motion between the kite and the air, and that's how you kind of do certain motion to make sure the kite is airborne. And then of course we have gliders, right. Gliders, hang gliders. You can look at these hang gliders, which a lot of people use for sports nowadays, right. I mean, it's fun activity. So these hang gliders, again, you're kind of using relative motion. You go, run fast and jump off a cliff. Uh, I guess it's adventurous to jump off a cliff, and then you use you look at, you generate aerodynamic forces through relative motion between glider and air, right. Similarly, other kind of gliders are also there. We also use gliders which are pulled by a winch, as in there is one string which kind of pulls it forward, and then because it generates relative motion, it moves at certain velocity, it gets airborne. At certain velocity, aerodynamic forces are generated and it's airborne. So these kites, hang gliders are all unpowered. I am not using any extra power source, no engine as such. So they are all only for shorter flights, right. They are not as practical, right. That's why they are used only for fun purposes, not really for any practical application. Other things that we more commonly encounter are basically your passenger aircrafts, fighters, bombers. If you look at all of them, they are all come under the classification of what we call as aeroplanes. Why are they called aeroplanes? Aero because they are airborne. Planes because if you look at their wingspan, that is the extent of their wing, and you look at their fuselage length, right, those are all like very large. The length of fuselage is typically similar to the length of your wing or span of your wing, right. Compared to those two dimensions, the height of your fuselage is very small. So height is very small, whereas the span of wing is very large, the length of fuselage is very large. So it's effectively like a planar structure. What is a planar structure? Planar structure is one in which the dimensions within the plane are very large, whereas the dimension in the perpendicular direction is very small. It's like a plate. And what do we call as a plate? Something that has large dimension in both within the plane, and out of plane the thickness is much smaller than other two dimensions, right. Similarly, even in this airplanes, the dimension wingspan and fuselage length are much larger than the height of fuselage, and so we call them aeroplanes, right. So these aeroplanes use fixed wing concept, right. There is a wing which is fixed, and you use some propulsion source, some engine, to push this aircraft and generate relative motion between aircraft and the air, right. For most part, air may be stagnant or there may be some wind, but mostly we are relying on pushing it using an engine, right. You push it using an engine. As it is pushed, there is relative motion between wing and the air, and that will give rise to aerodynamic forces, that is lift, and that lift will pull it upwards, right, and that's what makes it airborne. So these are all airplanes, right. Fighters and bombers, what are fighters? Fighters are used for dog fights and so on. Bombers carry some bombs and go bomb everywhere, right. So whatever it is, right. Of course, in India, NAL has been developing Saras aircraft, which is a transport aircraft, which is for like 18-seater and so on. And India has also developed fighter aircrafts like light combat aircraft, and so on. Right. So these are all developments that have happened in India in this airplane sector. Another set of aerodynes that we are very familiar with are not aeroplanes. Airplanes are fixed wing airplanes where, as I said, wingspan and fuselage length are much larger than fuselage thickness. Other set of things are what we call as rotor crafts, right? Rotor crafts are basically things wherein instead of having a fixed wing, here what is happening is there is one wing which is rotating, and we call that rotating wing as blade instead of wing. That's it. But fundamentally, they are similar in nature. They work in a kind of a similar manner, right? So these blades are rotating. The rotating blades again generate relative motion between the blade and the air. That relative motion between blade and air will generate some lift that will lift it up, right? The most common form of rotor craft that we all know is basically helicopter, right? We all are familiar with helicopters. Those are rotor crafts. Why are they called rotor crafts? Because wing is not fixed. Instead of fixed wing, I have a rotating blade, right? So they are rotor craft. So that also has a tail rotor and so on for balancing. That we'll talk about later. In addition to that, other common forms of rotorcraft that we encounter, I already talked about it, is quad rotor. But in general, quad rotor is a small subset of larger group, which is called multi-rotors. Could be quad rotor, wherein 4 rotors are there, or it could be hexacopter, where there are 6 rotors. Sometimes we want that 6 rotors for extra stability and so on. Alright, so these are hexacopters. And nowadays, there are aircraft which are right combination of an airplane and a rotorcraft and so on. So nowadays, hybrids are always popular. Hybrids kind of combine advantages of could combine advantages of both rotorcrafts as well as fixed wing. Right. So there's some of that work has been happening at IIT Madras, where we are working on a combination of rotorcrafts. Rotorcrafts can take off from anywhere; they don't need runway. So can I adopt that at the same time? If you look at all these rotorcrafts, they are very energy inefficient because of the way they function. We'll discuss that a bit later. Whereas fixed wing aircrafts actually consume lot less fuel. That's why even today, though it's convenient to fly in a helicopter because you can take off from anywhere, why is it that everybody is not using helicopter? Why are they using this fixed wing aircraft? Fixed wing aircraft means you have to go to a particular place called airport, right? Whereas a helicopter can land in if there is a field, it can land in that. Fixed wing aircraft needs a runway, huge airport, you have to go there, it will be like 20 kilometers away from your home and so on. So why do we do that, right? That's because it's a lot more fuel efficient and hence costs of operation are very low, correct? So anyway, so can I combine both? Can I take off like a helicopter from anywhere? At the same time, can I somehow make it more efficient like a fixed wing? That's where hybrid systems come. There are some of those things I'll also discuss at a later stage. In addition to this airplanes and rotor crafts, we also have this flapping wing structures or ornithopters or insectothopters, right? These are flapping wing structures. Again, this is more in the realm of, we are fascinated by bird flight. They have flapping wing. So we also try to, look at those flapping wings and see if we can adopt. Right? Flapping wings, again, not so practical because energy spent is a lot more. However, we may want to use it in certain stealth applications, as in if I have very small, I want to develop this very small UAVs which go in and then kind of do some surveillance without other person noticing. In a rotorcraft, the noise people may pick up, whereas the flapping wing structure may generate noise similar to a small bird or whatever it is, and thereby make them slightly undetectable, right? So it has certain niche applications. Ornithopters and insectothopters have certain niche applications, but not very wide range of practical applications. For most of the practical applications, it's typically your airplanes, fixed wing airplanes and your rotorcrafts. Those are the two important things that we use for most of our applications. This is regarding a basic classification of aircrafts. But then there is a huge set of systems which are also actually aircrafts, but for the most part, we don't think of them as aircrafts. For example, ballistics, rockets, missiles, they are also aircrafts because they are all airborne, right? They are all flying in air. What do we mean by ballistics? If you take a stone and throw, that is also ballistic. What does ballistic mean? I take this object, I throw it with some force or some velocity rather, I will release it with some velocity at some particular angle. Depending upon the angle at which I throw and the velocity with which I throw, the stone or the ballistic or the whatever the object will go fall at certain particular location. Once I throw, I have no control over it, right. This is just like throwing a stone. Once I throw the stone, I have control over what angle I throw it at, I have control over what velocity I throw it. But once I throw, it will reach a particular destination based on its trajectory, and that's it. There is no control that I have. That is a ballistic, right. In fact, one of the things about ballistics is guns are ballistics, effectively using ballistics, right. One of the things I keep telling a story is, a lot of times we hear about this gunfire across our western border, when they say when they report in news that our army exchanged gunfire with our immediate neighbor in our western border. We think of handheld guns. It's not like they are exchanging fire, means they are not taking a gun and shooting each other. The guns we talk about, we say gunfire exchange happened. The guns we talk about are these Bofors guns, right? These Bofors guns are huge. They are like 30 feet guns, right? So these are really, really large guns, and the projectiles that they are throwing are not really small like bullets, right, which will go kill an individual. They are talking about projectiles, which is a shell, and that shell, some of those shells are as big as 155 mm in diameter. 155 mm is 6 inch. 6 inch diameter is about yay high, right? About 6 inch, it's like your half scale. You have this plastic scale which is like 6 inches. It is that much diameter, and the length is 1 meter, right? It extends over 1 meter, right, length. And that is the shell which we launch, and that shell goes it can travel to 25 kilometers, 50 kilometers, and so on. So the projectile, the ballistic that we are, or the gunfire that we are doing, that gunfire involves the shells which are that big, like 1 meter long, 15 centimeter in diameter, and they travel for 25, 50 kilometers, right? They are all ballistics, right? And then there are rockets. What are rockets? As I said, in ballistic, once I throw, that's it. I don't have an onboard propulsion unit. Whatever velocity and with velocity and angle at which I chucked it or threw it determines where it falls. Whereas a rocket carries some propulsion system on board. So once I throw it, it will increase the range by pushing it further using my propulsion system. Rocket, right? There is a rocket where the hot gases come out and then push it further, right. So it extends the range from a ballistic. Now we went to rocket, wherein we just said, let me add another propulsion system there so that it goes for a longer distance, right. That is your rocket. Then what is a missile? You take the rocket again, all it has is propulsion system. It may not be very easy to control it. It just extends the range, but it may not offer you too much of control. Missiles are ones which can be completely controlled, guided, controlled, and when I launch, missiles are nothing but rockets with all these controls. Rockets where I can guide them and make them go hit exactly the location that I want it to hit. That is missile, right? So there are ballistics, which are like just dumb, you just throw it and forget it. Rockets which have onboard propulsion system to extend the range, and then missiles which make it easy to control the system. So each one is one step higher, right? Ballistics, then there's rockets, then there is missiles, right? Of course, nowadays again this kind of classification is slightly crude, because there are things which there are ballistics which adopt a little bit of onboard propulsion system. One of my colleagues is working on ramjet based propulsion to extend the range, and so on, right. So similarly, there are rockets which are kind of trade into the territory of missiles and so on, right. So these are all so anyway, the reason why I talked about ballistics, rockets and missiles is this is something that we don't often think of as aircrafts, but they are also aircrafts. Of course, the reason we may not think about them is mainly because it's in defense domain, not in civilian domain. So in that sense, we are not exposed to it as much. But they are also aircrafts. They also use same aerodynamic principles as our airplanes and so on. They also similarly, structures also use similar principles as your airframe structure and so on. And propulsion is also similar between the two. That's why what we study in this course will also help us design ballistics, missiles and rockets as well.